Hi, my name is Diana Riggs, and I did my book project on the Double Helix, a personal account of the discovery of the structure of DNA by James Watson. This book is basically about the different groups of scientists who were racing to figure out the structure of DNA, the key to life, and how Watson and Crick made it first. So I actually have a little quote here. It really helps, I think, put the mental picture into mind that science is not always straightforward. It's very messy, and sometimes you have to work backwards to get the answer you want. So, starting out, James Watson was not super interested in DNA. He was working with bacteriophages and was actually doing his postdoctoral work in Denmark when he went to see a presentation in Naples in 1951 by Maurice Wilkins. And Wilkins was talking about X-ray diffraction of DNA and the structure of it, and this is what really sparked Watson's interest in X-ray diffraction of DNA and the structure in total. So he left his work in Denmark so that he could start working in Cambridge with Wilkins, and that's actually where he met Francis Crick. Crick wasn't working on DNA either. He was actually working on protein. So both of them together decided that they wanted to work on DNA, and they became colleagues. And they actually wanted to recruit Wilkins as well, because he had the most serious studies going on at the time on the structure of DNA. But unfortunately, his lab partner, Rosalind Franklin, was not willing to share her work quite yet until she had presented it. So this kind of delayed Wilkins working with the two of them quite yet. So at this time, when Watson and Crick were on their own, Linus Pauling, a chemist at Caltech in the United States, had published a paper saying that DNA was helical. And so basically the idea of DNA being helical fit all of Crick's equations. It made sense, and so this is where Watson and Crick got the idea of model building, and so they started just to build models of the possible structures of DNA. I think it's important to note that Rosalind Franklin thought this was really childish, and thought that they were kind of like boys playing with toys, not really doing the research required to figure out the structure of DNA. So that wasn't all too serious to her. She wasn't really paying much attention, I guess, to the idea of the helix. Their main idea at this point was that DNA was 3-chained instead of 2, and that the sugar phosphate backbone was on the inside and not the outside. And so they were pretty off with this guess, but they had to start somewhere. So they asked Wilkins to come take a look at their model, and Rosalind Franklin actually accompanied him, and she took a look at the model and said that it was incorrect. It wasn't a helix, and that there wasn't enough water content in their structure to make sense. So kind of at that point, they gave up a little bit, and also the director of the Cavendish lab where they were working figured out that they were still working on DNA, and they weren't supposed to be. They were supposed to be working on their respected fields. So he made them give up DNA too. So then at this point, they were kind of at a low, and Watson started working on the tobacco mosaic virus. And in the tobacco mosaic virus, he knew that there were nucleic acids, so that was a good cover for him to keep thinking about DNA while he was working on something else. And so he found that the protein subunits stacked helically, as you can see in this picture right here. And so that gave him even more reason to suspect that DNA was helical in structure and it wasn't a linear thing. And so he brought Crick his idea, and both of them immediately got to work again, immediately jumped right back on board. And so at the same time, Erwin Chargaff had published his ideas on the relationships between complementary bases and base pairs. And so this kind of also fit Crick's equations and fit their model. So at the same time, Franklin was the one who proposed that the backbone could possibly be on the outside, but she didn't really have any evidence for this, so nobody took that quite seriously. Also, Pauling said that he had the structure of DNA and published the paper, and it turns out he had published a 3-chained sugar phosphate backbone on the inside structure, which was exactly what Watson and Crick had done before they became really sad and disheartened about it because it was completely wrong. And so Pauling made the same exact mistake, and through making this mistake, Watson kind of figured out some things, figured out that it was going to be the 2-chain instead of the 3-chain, and instead of the backbone on the inside, he decided it couldn't hurt to build it with it on the outside, and so he started messing around with that. And then at the same time, Maurice Wilkins, who was still working with Rosalind Franklin, but there was a lot of tension and pressure in between the two of them. Wilkins had actually been copying Rosalind Franklin's work, and so he had a photo that she had not released yet, photo 51. This photo definitely showed signs of a helical structure, and so he showed it to Watson, and Watson then pretty much figured out what it had to be. He knew it had to be 2-chained. He knew that it was helical, and he knew that the phosphate backbone was going to be on the outside. And so just a little bit of messing around, some minor tweaking, talking to a lot of colleagues, they figured out that it had to be, the complementary bases had to be equal. They had to be one on the outside, one on the inside, although they could be flipped so that they were still facing the same way. And the strands had to be complementary, so they were running the opposite way, basically 3' to 5', 5' to 3'. So after they had all of this figured out, they published their work, and afterwards pretty much all the scientists that really helped them out and gave them the research they needed to figure it out were happy with the findings. You know, it really sparked a lot more researches after that and influenced a lot of stuff. I mean, it's the finding of DNA. But so some examples of authentic science were when Watson and Crick were building the models of possible structures of DNA. Watson was not into math or chemistry. He liked neither of those subjects. He was more into the hands-on stuff. And so that's where his love for model making started. Crick followed along because he realized that his equations and building models actually really helped each other. And so they worked really well together, even though they were completely different spheres of science. Another example is that Rosalind Franklin always denounced the helical structure of DNA up until the day that Watson and Crick had figured it out. Even though she didn't like the idea of the helix, she figured out a lot of things that helped Watson and Crick make the final decision. And it was her idea that the water content was a lot higher than Watson and Crick had assumed. She had the X-ray diffraction photographs of DNA that showed the helical structure, although she didn't believe it. She had the greatest photographs, and so really without her, none of it could have been done. Also, another example I had, I have a quote here that I'm going to read from the book. It says, "Hurriedly they went through their respective mathematics and discovered that Bill had used an elegant derivation compared to Francis's more laborious approach. Gleefully, however, they found that they had arrived at the same final answer." And that just really shows that finding the answers in science can happen more than one way. There are different processes, and that's just the way science is. There's always more than one way. It's not just a linear thing. It's always changing, superfluous, and yeah, it's just there are a lot of different ways to do science, really.